Hello, hello. Welcome to ground destruction number 13. So we're creating this based on what I did previously. So this is the result to the left. Yeah, it's a bit of a messy one, but hopefully you learned something from it. Before we start, I created a Patreon not too long ago. I thought I'd never do it, but here I am. And if you are interested and you have Patreon, you can always go ahead and follow me there. I don't have any paid tiers yet, but I will eventually when I have something. So you can just follow me for free. The plan is to do longer, like quote unquote courses, and a mix of other things as well. And the link is in the description below. But now let's get into the tutorial. And let's get started with a geometry node. Gonna go with a grid. We are going to wanna use a mountain and a poly extrude. Let's make it a little bit longer, add some more resolution to this. Gonna go with the simplex cloud. And there we go. Let's give it some thickness. We also gonna wanna cap the backside. And I also wanna have a group for the front facing here so we can scatter some grass. Let's copy this over and do the opposite because we want to use this as a static collider in our solver. I don't need a group for this one. We can do a reverse. We're also going to want to scatter and do a fracture. Let's do this. And let's go with 200. And now we can just give this a null. Now on our sheet here, this is going to be the grass patch. The thick part of the grass, the top one with all the roots and whatnot. We're going to have this deform and bend. I'm going to want to do a cut in the middle. And then we're going to do 2 more fractures. So let's just get started with the first one. I'm going to use a draw. Let's look at both of them. Change the X-plane. Press enter and draw something like that. And now when we have this, we want to do make this into a plane. If we just do this, it's going to be the wrong direction. So just point normal. That's fine. Can make it be even bigger. What do we want to do next? Remesh it so we can noise it up and use a mountain again. I want to do on the Z plane, I think. Yes. And that's probably fine. Not sure if it matters really. We're gonna have a bunch of grass and whatnot. So one thing, we want to center this, because if we look at this, it's probably gonna be inside and shit. So we want to make sure it's center. You could also, in this case, it doesn't matter, but we could pipe that in. So it should be in the center of this. One thing to optimize this would be to remove a bunch of unnecessary cutting planes. If you have a lot of them, that can make the calculation or the fracturing a lot slower. So we can use a bound, take our object that we want to destroy. It's going to do this. We can just add a little bit of padding maybe. Like so. And then we use a Boolean intersect. Drop this in. And this is going to be a surface, and now you can see it's a lot more optimized. It's just, you know, much better, a lot quicker to calculate. And then we want to use a Boolean fracture. Pop this in like so. And that should be fine. What I want to do also is change the name to be ground underscore. We're going to use underscore. This is going to be used when we set up the constraints. Explode it. There we go. 2 pieces. You can also look at the name attributes. If you open up, where is it? There it is. Geometry spreadsheet. We can see we have name underscore or ground underscore 0 and then ground underscore 1 for our 2 pieces. Drop in a name for each, what's it called? For each named primitives. It's going to be using our name attribute here. So if we do a single pass, we can see it has 2 only. And in here, we can yet again do a scatter. I'm going to go with 60 maybe. Go with an RBD material fracture. Before we pipe anything in, I'm going to remove 1 layer. We don't need constraints. Make this a little bit more wobbly, so it's not so straight cuts. Set this to 0, input point, so we can use our scatter. And there we go. Exploded views. So these are going to be our grass patches. So we're going to be creating, let's see. We are going to create constraint stitches between these and also this first cut that we did. And these are going to be able to break. And now we just also need to fracture each of these big grass patches here. And these are going to just not break, and they are going to be just bending because we are going to use the RBD solver for this. And before that, we can just prepare for our point deform that we're going to use later. I just want to copy the name attribute into a new attribute. Let's call it deform name, and there we go. Oh, I see now that I actually forgot here. So we're going to use underscore because otherwise it will be dash. I want to use the same. There we go. Now we have got that sorted, and we've copied the name into a attribute that we're going to use later. Now let's run yet another for each named. And again, you know, we can see it works just fine. And we can make this multi-threaded as well. So drop down a compile block and turn this on. Now we are multi-threaded. Now you don't want to use multi-threaded on everything, so because sometimes it's not actually going to be faster for you. I guess it depends on how much you're doing or how many pieces you have. So for this, for example, it might not actually be faster to run it multi-threaded. On this case, it's going to, because we have a lot more pieces. Again, just drop a scatter. And let's say we want 20 for each piece. And I think we can just go ahead and use a Warnock fracture for this one. Let's just, I don't know how many we're going to go with. 25 maybe. And now we want to create our constraints. So I'm going to use a RBD constraint from rules. Drop that in here. And something is weird. Yes. So append and do underscore. So if we now look at this, the name attribute we have here, we now have 3 layers of fractures. You can also use an what's it called? adjacent something, connect adjacent pieces. That would be another way of going to create constraints, but we can just go with this RBD constraint from rules. And you have some options here if you want to have surface points, hinges, can give you different looks. We need to do some vex here to create those stitches. So take the constraint output, pipe it in here. We're looping through all of these constraints. So it's a one line with 2 points. These points have, of course, like a ID, you could say, a point number. They also know about the name attribute that they belong to. So there is a function that we can use, which is prim points. They're going to give us the correct point number. So let's do an int pts, make it into an array, prim points. And this only needs like the 0 input, of course, because we are on the first one here. And then you just do the prim number. And now we have that. Now what we want to do is get the name. So string pt0 underscore name, let's say. And I'm going to use a split function as well. We're going to split it by the underscore that we have in our name. Make this into an array, equal, and then split. Whoops. And what do we want to get? We want to have the name. So we're using the point function. Say we want to have the name and then the pts0. So the first point in our constraint. And then I want to split this by underscore. And that's it for that. Now we also want to change this to 1, of course. And this to 1. So we can look at it. Because these are variables. We can't see it in the spreadsheet. And they also only lives in this node. But if we make it into an attribute, we're going to be able to see it here and we're going to be able to access it later down the road, but we don't need that really. Something to keep in mind. Let's just call it A and then pt0 name. And here we have 4 items. So we have ground, we don't care about this. We care about these guys. Run some ifs. We are going to look for the pt0 underscore name. And let's look at our second fracture, which would be our third in our array, and say if you're not the same, do color just so we can see it. And now we have the stitches for our islands here. Now let's also make sure that these only belongs to the correct side. So because I don't want to have this, otherwise we're gonna have maybe some issues. So let's just also say and this would be that. It needs to be the same on the same side. Now we're not having this in the center, which is good. We can also then make a group out of this. Call this patch stitches. Yes. I'm just going to copy this and make another color. Let's do our center stitches. And of course would be this. Now we have our center stitches. Let's call this center stitches. I'm gonna copy this again. And what do we need to do? Let's see. Make another color. And there we go. I guess we probably need this as well. Like so. And these are going to be our soft. Let's just call it soft. Now we have all our constraints set up almost. we do need to configure them. So RBD Constraint Properties. Make sure we actually use the correct input. And then say, let's do the center stitches. This is going to be a hard one. Like so. Make another one. And this is the patch stitches. Also a hard one. And this is soft. Soft. And this can be soft like that. Let's lower the stiffness maybe. And there we go. So now we just need to merge these. You can also chain it. You don't have to do it like this. You can chain them one after another. However you feel like doing it. And say out constraints. Let's set up our pieces here as well. So we need to assemble it so we can pack them. We need to make sure that we aren't creating new attributes because then nothing is going to work. Or the constraints aren't going to work. And I want to also make sure that the outside here is going to stay put. So it's going to be inactive. I'm going to do this manually. Point. And we're going to call this stay inactive. And use the boundaries. Make this a bit longer. Oops. Like so. Like so. And then we can just copy this again. Say union. And then move this one here. And we're going to go with a attribute wrangle. Here we're going to say if group stay inactive. If that's true, it's going to be a 1. So 1 be true. And here we can say like I active equals 0. We are going to have to say that the other one is going to be active 1 because otherwise they will default to 0. Because we are modifying some of them, then all the rest is going to be 0 unless we say otherwise. And for now, let's drop in a DOP network. And before that, just make a null like so. Let's go in here. We're going to do the default things. Fact object. Yes. We need a rigid body solver. We need a constraint network. Gonna have a merge. Gonna have a static object. Reverse this or set it to mutual. Then the input order doesn't matter. This one is going to be our outpacked. And these guys, we want to have the constraints. So a merge, because we have multiple. Let's drop in a hard constraint relationship. Copy this. We also want to have a soft bullet constraint. Like so. And now it should work. Oh yeah. We also need to actually drop down our out constraints here. And there we see it works. We can hide the guide object. And if we press play, we don't see anything because we need a gravity. So let's go with a pop force. And let's just say minus 9.8. Because that's the default value for gravity. And there we go. Before we do anything else, let's just also make sure that our constraint can actually break, because they're not going to break. So we need to actually make something about that. So a subsolver, drag that into the constraint solver here. Take this out, be on the relationship geometry, primitive wrangle, because these are primitives. And let's just, in case we want to have different threshold for different constraints, we can do constraint name equal this, and then you say like if angle, we're gonna go with the angle. If it's greater than, and this word I'm gonna call it center. And if this is all true, go into broken, which is a known group for the solver. Oh yeah, so we need to have this, of course. Constraint name. Okay, like that. Let's say this is like 0.5, 0.05. Copy this for our other one. This is, I have a bad memory, so patch stitches. And this is, so let's just call it patch or whatever. Do like so, maybe something like that. If we were to run this now, it should break, and it does. Doesn't look too fun, but 0.35, 0.25. Yeah, it's something for now. Now, for our force, you could have, oh, by the way, before that, we can actually bring in our collider here, static collision. So that is what we did in the beginning. If I not show the top one here and look at this, so I'm also not going to see this. We can look at the collision. So this is our collision. It's not going to work. You could say concave, it's going to be a perfect match, but it's going to be slower. So that's why I made cuts or fracture it. So we can just click on this button here, and it's going to use the names and kind of generate a collision per piece here. Turn this on again, and everything should be fine, which it is. It's also slow, but we're going to fix that. We're going to optimize this and make it faster. So now let's create the force and velocities that we need. I'm gonna want to use the draw curve that we have here. This is where we create our first cut. I'm going to ray this first. No, ray. And do the collision for this. And well, maybe it's not necessary. Let's do it anyways. Like so. Do an object merge so we don't have to have lines all over the place. And just drag this here. And to create our velocities, we're gonna create velocities on our packed fragments we have here, packed objects. So let's go with a wrangle. Take our line, put that in the second input. And to be able to see our velocities, we're just gonna temporarily remove the geometry so we only see the points. So we have our line. We need a position. We can use the min pos. This is a vector, of course. And it's going to be on our second input, this one, because we have it input here. And we want to have the position, our current position for our points here, for our packed. And now when we have that, I know we also want to have the distance. So let's do a float running a distance function. So do our current position and the pos. We also gonna want to have the direction. So dir, let's call it dir, and do pos minus p. And if we just temporarily put that dir in here, do times 10 maybe, we can see what we're getting. Click this, and here we go. This is the wrong direction, however. This goes inside now, so we need to flip this around like so. And now we have the correct one. So from our center here, it goes, you know, to the left or right. We want to have this pushed up. So how do we do that? Let's create a vector. I'm going to call this up. You can call it whatever you want. I just want to say, hey, look up. Maybe we should normalize the direction as well. So normalize the direction. And now they should all be the same size. It's just easier to control everything as things are normalized. So we're going to run a vector, let's call it result. And in here, we're going to use a lerp function. This is a mix function. Takes two values. And then the third one is a mix between the two values. So we're going to use the dir and our up. And then we can call this, I don't know, mix one, let's say, because we're going to do a noise as well. And if we look here, if we do 1, it's up. And if we do 0, it's going to be our direction. So let's have a little bit of up and away, like so, maybe. That's probably fine. Let's create a noise as well. Let's do that here, vector. Oops. Let's call it ns. And we can use an O noise. And just pipe in our position. And now we can do a result again and do a lerp. And do a lerp on the result and ns. And then we can call this mix2. And now we're noising it up. Maybe I can just do so now. So we have the noise at 1, nothing at 0. So let's just noise it a little bit, like so. Why I'm not doing this is because we already initialized it, the variable. So it's cool. Something else is, let's also multiply this by the distance. So if we do this, we're going to get like the opposite effect. So the closer you are, the more to 0 you're going to be. So we need to remap this. Fit. And fit it by, let's see, it's a 0 to 1, let's say. And do, let's call this strength to 0. Maybe something like that. Look at this. And there we go. 2 maybe, like so. That's fine. Cool. We have something. So we have this is now in the velocity. So let's do a vel instead. I don't want this to be put on our packed right away. So vel, or call it whatever you want. And that's probably fine. Now we also, another thing is, I want to animate a point here that goes from left to right or right to left. Extract and animate, alt click, do 220 maybe, alt click. Now we have an animation. There's some bugginess here, so you can always do a viewer, new scene view. And now we don't have that shit anymore. Perfect. Shift click and make this linear. That's fine. Add a null. And let's again go back into our DOP. A pop wrangle we need. We want to take in our force. This is the the point that we animated. Let's get the position of this. So position is going to be a vector, of course. Let's call this, say, center point 0. Get the position. It's just 1 point, so 0 there. So 0 being this one, input 1. So now we have the position. Let's also get the distance. Float distance function. And let's do our position for each of our packs and the force. Let's use an if and say if this distance is lower than, call this thrash. If that is that, then for now just add a velocity, take the val that we created, put that into the velocity. If we were to play now, we're seeing nothing. And why are we seeing? Okay, of course. Let's say 2. And there we go. Looks pretty bad, but we'll fix that. Maybe we want to make this a bit stronger, perhaps. So that's fine for now. So what we need to do now is optimize this. As you can see, it's pretty slow. What are we getting? We're getting 4.5 frames per second. So let's optimize it in here. So the ones that are going to stay inactive, we want them to just, well, be active 0 and also use a bullet ignore 0. And on this, I want them to be inactive as well at first and use the bullet ignore equal 1. So it's going to be ignored. Well, so now it doesn't actually do anything. And to fix that, we, instead of adding the velocity, we want to say, if you are within this threshold, I want you to be I at active equal 1. And then we need to kind of, we can't just set bullet inactive 0 here because it's not going to look correct. So we want to just do like a little bit of offset, maybe 0.5, and set the bullet ignore to 0. And of course, nothing happens. Let's just do a v at v equal. So it's a lot faster. It doesn't look good, but quite a lot faster. Maybe we could also, suppose we could maybe optimize this as well. Let's just try it. Convex decomposition. Let's do that. Convert it. It's even faster now. So I think it's faster. We got 13. If we don't, we get, well, we actually, oh yeah, it's a little bit faster. Turn this on. And maybe even we can do a poly reduce. Who knows? Let's remove 50%, maybe even less. Let's just try it. Maybe that's fine. Let's do 45, or let's go with 50. Now, of course, it looks like shit. We need to do something about that. Let's... Did I mess something up? Yeah, okay, so the position only is what we want to have. That's going to be a lot better. So now we're actually getting somewhere. Looks half decent. Now, what I want to do is create a timer for when they are active. So what I'm thinking is do initialize start time. We're going to if you are active and do a distance less than -1, maybe. And I at start time. If you're not, so if you haven't got anything in the start time, or if it's like 0, we want to do something here. I want to create a group action. We also need to give the start time the current frame. And let's also make a duration. Duration equal I at start time +2, let's say. Then we also want to make sure that we move them out of the action group after a certain time. So if you are in the group action and frame is greater than duration, then just do not be in the group action. And we can look and see, does it work? It do work. Because they are not the same values, then we know that it actually is working. And it just offsets here with 2 frames for the duration. And that should be fine. Let's drop in a new pop wrangle. Let's say action. Everything in the group of action. And now we can do a v equal v at vel. And let's see. We're getting something. Cool. We need a little bit more push. So multiply that. Maybe that's too much, I don't know. Maybe that's fine. Looks decent. We can see how it looks without our like optimization here, because this will obviously change our object a little bit, so the collision is going to be a bit different. See, maybe we like this look more. And I guess this actually looks better. Let's see without the poly reduce. Yeah, let's go with that. That's fine. It's pretty basic, but it's decent. So I'm happy with that. Now let's use the point deform and all that good stuff, so we don't have to see this ugliness. And to do that, I'm going to use a DOP import. Drag this in here. We only want the RBD packed object and not our collider. And I'm thinking we need this. This is before we did the small fractures. And the idea here now is to end up with a working point deform. So what do we need to do? We need to unpack this. So we could use this, or we could take this more detailed one. It's going to be this one. Let's just see what we think looks best. Let's start off with this one. So we want to unpack it. So we don't want to do it every frame. So time shift and make sure it's on the first frame or whatever your first frame is. And then we do an unpack. Unpacking it. And let's do a transform pieces. Transform this. Not like that, something like that. No. Let's see. Oops. So template points. Oh yeah. Like so. So. No. I guess not. Why are you not working? We do need. Oh. This is the one. Okay, cool. So now we are transforming this unpacked one using these guys. And we now want to point deform it. So let's see. We're gonna do point deform like that, and let's drop this in here. And we want to use the deform name that we created. And there we go. And normal's a little bit off, so just click on this one. Do not recompute the normals. And I think this is fine. Let's see if we use this one. It's a bit slower, but I suppose it's gonna deform better. So let's just go with that. So before we drop in the grass, let's see if we can tweak this a little bit. See what we have so far. That's what we have. Could perhaps lower the stiffness. Not sure if I like this. Let's see. Put that to 5. Let's see. Maybe we can not relax. See what we get. Maybe that's fine. Maybe we can also give this a go. Let's see, we can scale these guys down. And primitive properties. And do transformation. Scale it down to 0. We're gonna have to update the rest length as well. At rest length 0 now. So before that, it was calculating the length of each constraint. But since we scale it down, we now have to set it to 0, otherwise it's gonna pop. See what we get. I don't really like this. Nah, that was bad. Remove this. Change the damping. I mean, I guess we can tweak this all day long. Maybe we should change some of the physical properties. Yeah, let's have it like so. And we could cache this out. Let's do that. See, do we have a bunch of unnecessary? No, we don't have. So when you cache something out, you want to remove as many unnecessary attributes that you don't need, because it's going to make the file sizes a lot larger, and it's going to be slower to the playback is going to be slower. Let's do a file cache and time dependent. Yes, let's do 120 frames. I'm gonna change the timeline as well. So we are not we're not running at full speed, so we can just drop down a cache as well. I think this is fine. Just gonna cache it, and now we're at full speed, so we can have real-time playback. Nice. I mean, it looks kind of weird, but it's fine. You will have to tweak your scene more. So what we want to do now is we want to scatter some stuff, some points that we were going to use as grass. And then we'll have a look at the rendering. Okay, so let's scatter some grass. So we have some here. You can find it on Quixel or Poly, what's it called? Ah, slipped my mind. There's plenty of sites out there, at least. Quixel is one of them. But let's go on with this. We want to scatter some points so we can copy our grass to it. Now we can't just do this. It's going to do this every frame. And we can see this here on this little time clock that is time dependent. We want to do this on the first frame. And I'm just going to Alt Shift click to just have one frame. So how do we transfer over the position? We can use a adjust, what's it called? Attribute interpolate. We do this. Let's turn on these guys, source prim and source prim UV, because that's what it wants. And if we scrub now, we can see that it is moving along nicely. Some other things we want to do is promote the normal, promote attribute, or attribute promote. This is going to be on the vertex, I believe it is. So now we have that, and it's already, it takes all the point attribute here, so that's fine. And before we do anything else, let's just do a copy to point so we can see something. I'm gonna take this one perhaps. Oh yeah, before that, we of course need to, I'm gonna delete some attribute because it has some bullshit attribute that we don't need. So FBX, anything with FBX. I'm also gonna remove the color, and then I'm gonna pack it with just 1 point. And we can just transform for now. Make this, I don't know, 0.02 maybe. And also we want to rotate this 90 degrees X. Oh, and by the way, we actually want to scatter onto our extruded front as well. If we now have a look, why are you messing with me? Oh, it is correct. Yeah, it is correct. Looks kind of weird, but it's because of this. Okay, so now we have that. I guess we can just keep on, we can copy this over like so. Take these guys, this, do a merge. Like so. And create variants. We can use a connectivity. So what that does, it gives us a class. We can call it whatever we want, but I'm gonna call it variant. In here, we can do an integer attribute adjust, or what the fuck is called? Attribute adjust integer. It already says variant, so that's good. We can do random 0 to 2. That's good. And here we basically say variant. So now we should have a variation of these. I believe, yes, we do. Something else would be to maybe, first we can just up the numbers here. 10,000, sure. Now we're gonna have to rotate this. Before we do that, just do a attribute randomize. Gonna randomize the p-scale. This dimension 1.7 to 0.9 maybe, or 6. Let's go with that. And of course we want to randomize this. So we're gonna do this here because when we do this, it needs to be rotated correctly based on the current normal of our object here that is deforming. So let's add a point wrangle. And in here, we're going to use a rot attribute, p rot, so it's going to know about this. And it's a quaternion. So we do that, it's a quaternion function. I know that it's going to want to have radians. And then we're just going to do a rand function on our each, the pt num. And we're going to want to have we're going to want to rotate this on the normal. And let's see, This is gonna have to be a fit. So fit 0, 1. And here we're gonna do from 0 to 360, but we can do a channel so I can show you how it looks. Angle or whatever. Let's see, what do we do wrong? Do we need another one here? Yes. Edit parameter interface. Set this to 360. And if we were to up this, it's going to rotate. And if we also look at some weird, when it has some weird face here we can see, so it's, you know, have that kind of direction, the normal. So if we rotate, it should rotate along the correct normals. I have a few other that aren't grass. It's like these kind of things. So let's just do some more scattering. I'm gonna do this on a separate one. Let's just add another time shift, whatever. Copy this one. Let's make this like 1,000 maybe. Let's not have relaxed. Maybe that's too much. 500. Variant. It's gonna be 2 variants. 0 to 1. P scale fine. And we need this. Do that. We need this as well. I'm gonna do this and that, and I'm gonna take these, and what do we get? We get something like this, and maybe that is too small. We can go ahead and update the transform a little bit. Maybe that's too much. I don't know. Let's say something like that. That's fine. We can merge these guys in like so. And this would be null. And let's take also this one. And I'm just going to make yet another null. And I suppose we should have made UVs. Maybe we can do that here. There we go. Let's see. Let's have it like this for now, and let's see when we get to the render stage if we need to do something else with this before it's just something like that. That's fine. So before we start doing some test renders, we need to make sure that we have some velocity, which we don't have. So I probably lost it somewhere, but we can drop down a trail, put it here, set it to compute velocity. And now we have velocity. And that should also transfer over to our grass. See, there we go. We have that. And some other thing is, so we have this, right? Gonna put a texture here, but we can make the rest to be, I guess, just a color or something. A primitive wrangle, and say extrude front, not extrude front, and let's just call this, I don't know, at brown color, and have that. And we can also make proxy for our grass. And I'm just gonna do this like so, and that's it. But if you want to instead have like, I don't know, some cubes or whatever to represent your grass, you can use a copy to point. You might also want to reduce it, which I guess we could do. I don't think it actually matters, but we can just do it. So let's do rand ptnum. If it's above 0.5, let's just remove half of them. Even less. Let's just do that. This is going to represent our grass. And also call this proxy. And let's move on to stage environment here. We're gonna do an import, sub import. This didn't change, so let's do that. And here we are going to take the ground. So we have that. We also want to have the grass, and we want to have the proxy. Drop down a sub layer for this, like so, and we're gonna have a primitive, configure primitive, and set this to be render, and this to be proxy. I'm gonna also call this grass proxy. This is ground, and let's drop down a material library like so. Do a merge, take these guys, and there we go. We see the points only, and we don't see the grass. So when we render, we are going to see the grass. We can, I don't know, let's say a merge. I'm gonna drop down let's do a Karma Sky Dome. Fill in some values here, I don't know, we'll see. So this is like, I guess, the time of the day or whatever, how high it is, and I just don't know exactly. I'm just, playing with some value until you get something that looks half decent. We're also gonna want to have a camera, so by placing yourself somewhere and then say new camera, and there we go. And drop down a karma as well. And I'm going to set this to be XPU. Let's do 16 for now. What I'm going to do is I'm going to turn off the color correction, and we can just burn this shit into our render, the tone mapping. So I'm going to go with aces. You could also not burn it in, but for this I'm just gonna do this. I think it's fine. Let's also create I'm gonna start off with creating the material for the grass. So let's drop down a material X builder, call this grass, and I've just really just added in the albedo as a color. We got the opacity as a float, and translucent. I'm just not going to use the translucency at all. Skip that, and we can just autofill. And one thing is, if we look at our spreadsheet here, we can see we are using packed because we have the prototypes here. So these are the 5 different grass objects that we have, and then these are like being referred as, whatever it is here. And I'm not sure which one is the best for memory, but I'm just gonna go with create point instancer instead. I'm not sure how much it matters, but we're gonna go with that anyways. Now I'm just gonna, let's just, I don't know, do that. Star everything. And there we go with that. And if we want to render this just to see one thing, press D and make sure viewport size is on here. I believe default is this, so that can make it really blurry. So it's better to just have the viewport size. And let's just look at this. And of course, like this. And let's see, change this. Something like so, maybe. And there we go. We have something. We can also look to see so that our velocity works, motion blur, which we can see it doesn't work. I'm just gonna render that like this. Make sure we are looking through the camera. And let's go camera effect. Turn on velocity blur on both, because this one is going to be for our ground. This one is going to be for our instances. And it should work. And I guess it has motion blur, which is good. And if you want to make this bigger, you would just can change the shutter open and close. But I'm just going to keep it at 0.25 and be okay with that. Clear the region. Now let's look at the ground. Just going to turn this off for now. So I just copied in something I had before. This isn't really a rendering tutorial, so, and it's not actually looking that good. It's pretty ugly actually. Let's see. What do we have here? If equal. And here we go. So this is the, what do I call it? Brown. Integer. Like so. So really what this does is, this is the geometry property value. So when we created that brown, let's see, object, we created somewhere. So this will be here. We created brown attribute. We can access that in our shader. And that's what we do using the geometry property value. And then it's just a if, basically. And yeah, that's probably okay. And that is really, like, that's pretty much it. You would use this to render this out, render the disk. You can monitor it. So mplane monitor, I believe that's the one if you want to see every frame getting rendered. Yeah, that's about that, I think. Of course, you want to turn this up Because even though you might not see much noise, you might not see much noise when you're just looking at one frame, but then when you look at like play the rendered frames, you will see a lot of noise. And if you want to lock the noise, you can do so in somewhere. Let's see. Here it is. So like lock random 1, I think. This is gonna basically, the noise is gonna be at the same place all the time. Now that may or may not be a good thing. Kind of depends. Sometimes you can get away with less samples if you just lock it. It's gonna be less noticeable, but this can all depend on your scene and all of that. Just gonna run this out like so. And some other things you could do for fun is to use lens shader and yeah. Drop a physical lens karma and just gonna copy this. Just gonna turn down this for now. And see, lens distortion, chromatic aberration. And we need to turn this on more. So we have some chroma. This is taxing on the computer for whatever reason. You have some other things here. So yeah, that's about it. So well, thank you for watching. See you in another tutorial.